In section 3.5, we're going to look at the derivatives of trigonometric functions, and we're just going to deal right now with the three primary ones. So the derivative of sine x, cos x, and tangent x. So if we revisit the sine curve, this is our basic sine curve, starts at the origin, oscillates up to 1 and to -1, and takes 2 pi to complete one rotation. And if I was to graph the derivative of sine x on a graphing calculator, you would end up getting the cos curve. So that is why the derivative of sine is really cos. Similarly, we could show that the derivative of cos is actually equal to negative sine. So say we are asked to differentiate the following. Well, y equals sine 3x. Again, this is a composite function because 3x is really inside my sine function. So to take the derivative, the first thing I do is I take the derivative of sine, which is going to be cos, and the 3x just tags along. And then I have to times by the derivative of the inside, which is 3x, or 3. So my final answer would be 3 cos 3x. Similarly, this is another chain rule. I have a trig function inside of, I have an x squared plus 2 inside a trig function. So the first thing I'm going to do is take the derivative of sine, cos, which is negative sine, x squared plus 2. And then I have to multiply it by the derivative of x squared plus 2, which is 2x. And remember, the 2x is being multiplied by this entire thing. So I'm going to move the 2x out front, times it by the negative, so it's negative 2x sine x squared plus 2. Okay, in our next example, I'm showing you the difference between a sine x cubed and a sine cubed 2x. These are two totally different strategies here. This is no different than our first example. So to take the derivative, I take the derivative of sine first, which would be cos x cubed. And then I times everything by the derivative of x cubed, which is 3x squared. So it's 3x squared cos x cubed. Now, for question D, the first thing I'm going to do is I'm going to rewrite this, because this really means sine 2x all to the power of 3. That's what sine cubed 2x means. So now I have to use the chain rule first. So the 3 comes out front. The sine 2x drops to a power of 2. And now I have to use the chain rule again for the derivative of the inside. So I take the derivative of sine, which is going to be cosine, and the 2x tags along. And then I times this all by the derivative of 2x, which is 2. So my final answer would be 2 times 3 is 6. Then I have my cos 2x, and then I'm going to move the squared back there, and that would be your final answer. Now the order you write these doesn't matter because we're multiplying in order doesn't really matter. Okay, in the next example, again, this is a cos cubed, so the first thing you should do is rewrite this as cos x squared minus 5 all to the third power. So to take the derivative, the 3 comes out front, and the cos x squared minus 5 drops to the power of 2. And then I have to times it by the derivative of the inside, which again is going to be a chain rule. So the derivative of cos is negative sine x squared minus 5 times the derivative of x squared minus 5, which is 2x. So multiplying now, I have 2x times a negative times 3. It's going to give me a negative 6x. I have sine x squared minus 5. And I'll bring that 2 back in front to be cos squared x squared minus 5. Okay, in the next example, I have a product rule. This is my first function. This is my second. So again, y prime is going to be my first function times the derivative of cos 4x plus 2, which I have to use the chain rule. So the derivative of cos is negative sine 4x plus 2 times the derivative of the inside, which is 4, plus my second function times the derivative of the first. So now 4 times negative times x squared is going to give me a negative 4x squared sine of 4x plus 2, plus I'll bring the 2x out front, cos of 4x plus 2, and you could technically factor out a 2x if you wanted to get your greatest common factor. So this would be a negative 2x sine 4x 4x plus 2 plus cos 4x plus 2, and that's your final answer. Lots of people want to factor out this 4x plus 2, but that 4x plus 2 is inside those trig functions, so you can't factor that out. And again, this would be your final answer. Okay, this question here you have to be a little bit careful of. This is a trig function within a trig function. This is not a product rule. If it was cos x sine 2x, then it would be a product rule, but it's not. So again, first thing I need to do is take the derivative of that guy. So y prime is going to be negative sine of sine 2x. And then I have to multiply it by the derivative of sine 2x, which is going to be cos 2x times the derivative of 2x, which is 2. So your final answer, the 2 times the negative will be negative 2 cos 2x sine of sine 2x. And again, that's your final answer. This is not sine squared 2x, it's the sine of sine 2x. Okay, in the last example, this is a product rule again, or sorry, not the last example, but our next example. So again, it's a product rule. It's going to be a chain. So the first thing I need to do is I need to rewrite this as sine. Let's see if I can clean that up. X squared plus 1, that's all cubed, times cos 3x all squared. So y prime is going to be the first function times the derivative of the second, which is going to be the chain rule. So it's going to be 2 times cos 3x all to the first. And then I have to times it by cos 3x, which is negative sine 3x, times the derivative of 3x, which is 3. So there is my first function times the derivative of the second. And I'm going to run out of room here, so I'm going to say plus. And again, just continue this horizontally in your notes. The second function, which is cos 3x all squared, times the derivative of this guy, which is the chain rule again. So it's going to be 3 sine x squared plus 1 to the second, times the derivative of sine x squared plus 1, which is going to be cos x squared plus 1, times the derivative of x squared plus 1, which is 2x. So again, there's my second function times the derivative of the first. So let's clean this up a little bit. So I could multiply in the first term the 3, the negative, and the 2. So that's going to give me negative 6. And then I'm going to have cos 3x times sine 3x times sine cubed of x squared plus 1 plus, now in my second term, I have a 2x and a 3, so I could have a 6x. I'm going to run out of room, so I'm going to move this over a bit. I'm going to have 6x. And then I'm going to have cos squared 3x times sine squared x squared plus 1 times the cos of x squared plus 1. So now again, I have two terms, and I can look for my greatest common factor. So for my greatest common factor, I could take out a 6, I could take out one of these, and I could take out two of those. So y prime is going to be 6 cos 3x, and I could take out a sine squared of x squared plus 1. So my final answer here, when I take a 6 out of there, I'm going to be left with a negative. The cos 3x is gone, so I'm left with negative of sine 3x times a sine x squared plus 1, plus, if I take a 6 out of this, I'm left with an x. I'm left with a cos 3x because I've taken one out. I've taken out two of these, and I'm left with just my times cos x squared plus 1. So again, that does get a little bit ugly. Again, I don't know if I'd give you one quite that challenging on a test, but again, it's the process here that we're concerned about. Okay, if we take a look at our next example, this is an AP multiple choice question. It wants us to find the equation of the tangent line to the function y equals x plus cos x at the point 0, 1. So again, first thing I need to do is take the derivative. So it's going to be 1 minus sine x. And I want to calculate the derivative at the point where x is 0. So it's going to be 1 minus the sine of 0. So the slope is going to be 1. So there's my slope. There's my point. Now I can use y minus y1 and mx minus x1. So y minus 1 is going to be 1, x minus 0. And if we clean this up, I'm going to get y equals x plus 1. So my answer would be B. Okay, here's another question you can try, and I'm going to leave this one for you to try. So pause the video here and give this one a whirl. Okay, I'm hoping you had a chance to try this. And if we look at this question, I need to use the product rule. So it's going to be the first function times the derivative of sine 2x would be cos 2x times 2, plus my second function, which is sine 2x times the derivative of the first, which would be 2x. So if I just collect like terms, I'd have 2x squared cos 2x plus 2x sine 2x. And again, that's not one of the answers, but if I factor a 2x out, I'm left with x cos 2x plus sine 2x. And my final answer would be this answer right here. So there would be your final answer. And again, the order doesn't really matter because we're adding inside my bracket here. Okay, another example, we're asked to find the equation of a tangent line to the curve y equals cos 2x at the point where x is pi by 4. Well, the first thing I need to do is I need to find my y coordinates. So I'm putting pi by 4 in here, which is going to be the cosine of pi over 2, which is 0. So now I have my point pi by 4 and 0. So now I'm going to take the derivative, which is going to be negative sine 2x times 2, which is going to be negative 2 sine 2x is my derivative. Now if I evaluate that at pi over 4, it's going to be negative 2 times sine of 2 times pi by 4. It's going to be negative 2 times the sine of pi by 2. And the sine of pi by 2, if you look at the unit circle, we know that that is 1. And negative 2 times 1 is going to be negative 2. So now I can form my equation, because I'm going to use y minus y1 is equal to m x minus x1. So it's going to be y minus 0 is going to equal negative 2 x minus pi by 4. And if I simplify this, it's going to be negative 2 times x minus pi by 4. And so that would be answer C. Okay, in our last sine and cos example here, we have another AP calculus question. So again, I'm going to rewrite this as cos x cubed all squared. So when I take the derivative, it's going to be 2 cos of x cubed times, that's going to be all to the first, times negative sine of x cubed times 3x squared. So this ends up being, if I collect my coefficients, negative 6x squared cos x cubed sine x cubed, which is going to be my answer D. If we know our sine and cosine derivatives, we can use those to help us develop a derivative for tangent. Because if you remember from pre-calc 30, tangent x is really the same thing as sine x over cos x. If we apply the quotient rule, it would be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the denominator squared. So y prime would be cos squared x plus sine squared x all over cos squared x. And if you remember our trig identities, cos squared plus sine squared is 1, so I get 1 over cos squared x. And if I move cos squared up to the top, it becomes its reciprocal, which is secant squared x. So therefore, the derivative of tangent, okay, is really secant squared. So if y equals tangent of u, then y dx is going to be secant squared u times du dx. So it's to take the derivative of tangent is secant squared, and then I times it by the derivative of the inside, which is du dx. So in this particular case, I get y prime is equal to, 3 is a coefficient. The derivative of tangent would be secant squared x squared, and then I must times it by the derivative of x squared, which is 2x. So this would be 6x secant squared x squared. Derivative of a cow, anyone know what that is? Obviously that is prime rib. Little math funny. Okay, our next example, we're given that y is tan to the fourth of 3x to the fifth. So again, the first thing is going to be tan 3x to the fifth all to the fourth. So y prime using the chain rule would be 4 tan 3x to the fifth cubed times the derivative of the inside, which would be secant squared 3x to the fifth times 15x squared. So again, 15x squared times 4 would be 60x squared. Well, that should be x to the fourth, sorry. 15x to the fourth. This would be a 4, and then I'm left with tan cubed of 3x to the fifth and secant squared 3x to the fifth. Okay, in our last example, we're asked again to find the derivative at pi by 6. So f prime is going to be secant squared 2x times 2, which is going to be 2 secant squared of 2x. And if I want to evaluate this at pi by 6, it's going to be 2 secant squared of 2 times pi by 6 is going to be pi by 3. If we get our pi by 3, that's really 60 degrees. So this is going to be 1 root 3 and 2. Well, cos of pi by 3 is 1 over 2. So secant is the reciprocal, which is 2 over 1. So this is going to be 2 times secant squared is really going to be 2 squared, which is 4 times 2. It's going to give me an answer of 8. And there's your assignment from your Calc 30 textbook as well as your AP textbook. So give those a try, and if you have any questions, feel free to come and ask.